Hello student, today we are discuss about the properties of stationary wave. In last lecture we are discuss about the stationary wave and also we can discuss about the what is meant by stationary wave and how it will be formed on this stretched string. For that purpose we have to consider that the string that is which is fixed and stationary waves are produced, that is here the nature of stationary wave is like this. In this diagram, node and antinodes are alternatively produced. If string is fixed between these 2 points, then when two identical, in last lecture we are discussed about that. When two identical simple harmonic progressive wave travel along the same path but in an opposite direction, they interfere with each other, then stationary waves are produced. Therefore, here first property of the stationary wave, we can say that the definition is how stationary waves is formed. From that it is clear that we can see here in this figure when these two identical simple harmonic progressive wave travel along the same path but in an opposite direction. The direction of this wave is like this and another wave is like this. Therefore, these two waves interfere. These two waves interfere with each other and resultant wave is obtained in the form of loop. This here we can see in this figure. Loop is formed. ज्यावेळेस एकापेक्षा दोन वेव्ह ह्या प्रोग्रेसिव्ह वेव्ह एक सेम पाथ मधून जात असतील आणि त्या दोन वेव्ह जेव्हा कंबाईन होतील, इंटरफिअर होतील किंवा कंबाईन होतील, त्यावेळेस काय तयार होईल? रिझल्टंट वेव्ह जी आपल्याला मिळणार आहे ती कशामध्ये मिळणार आहे? लूपच्या फॉर्म मध्ये. लूपच्या फॉर्म मध्ये मिळाल्यानंतर रिझल्टंट जो लूप आहे त्याला काय म्हणतात आपण? स्टेशनरी वेव्ह. Therefore, definition is when two identical simple harmonic progressive wave interfere or superimpose on each other, then resultant wave is obtained in the form of loop and that loop is called as stationary wave. Therefore, first property of the stationary wave, we can say that when two identical simple harmonic progressive wave travel along the same path, in exact in opposite direction, travel along the same path but in an opposite direction, then resultant loop is formed. That loop is called as, we can say, stationary wave. It may be stationary wave, it may be transverse or longitudinal wave. When transverse, we know that in last lecture we are discussed about that. The transverse wave means the wave in which particles of the medium vibrate perpendicular to the direction of propagation of wave. Then that type of wave we can call transverse wave. And the longitudinal waves means the wave in which particles of the medium vibrate parallel to the direction of propagation of an wave. Then that type of wave we can call, that is longitudinal wave. During the propagation of this stationary wave, when this two identical progressive wave is, suppose it is transverse wave, when two identical pen to identical transverse transverse progressive wave interfere with each other, then resultant wave is obtained is also transverse stationary wave. Therefore, resultant wave we can call as transverse stationary wave, in which vibrations are perpendicular to the direction of propagation of wave. Then, during this propagation of transverse wave, we can say that node and antinodes are formed. Third, that is node and antinodes are formed. Node and antinodes are formed. There are formation of this transverse progressive wave. Then we can call there are some points which are motionless, which do not move. Some point which do not move. Then that point we can say that node. And there are some point at which amplitude is greater. Then that point is called as antinode. Therefore, we can say that node. Node means it does not move. It does not move. And antinode means greatest amplitude. Greatest amplitude. Then that point is called as antinode. Then these points of this antinode and node, it vibrates between 0 and 8. Then next property is the distance when two identical longitudinal progressive wave superimpose on each other, then we can get resultant when two identical longitudinal progressive wave superimpose on each other, then resultant wave is longitudinal stationary wave. Then after that, longitudinal stationary wave, during the propagation of this longitudinal wave, here node and antinodes are formed. There are some point at which amplitude is 0, then we can call node. And there are some point at which amplitude is greater. Point vibrates with greatest amplitude, then that point is called as antinode. And the point which vibrates with small amplitude, then that point is called as node. The distance between two successive nodes, distance between two nodes is lambda by 2. Here, distance between two node or two antinode, distance between two node and two antinode is lambda by 2. And distance between one node and one antinode is lambda by 2. Distance between node and antinode is lambda by 4. One node and one antinode is lambda by 4. This node and antinodes are alternatively produced during propagation of this stationary wave. This node and antinodes are alternatively produced. And the distance between two successive nodes, this node and this node, is lambda by 2. And the distance between one node and one antinode is lambda by 4. Amplitude. Here amplitude varies periodically in space. Amplitude varies periodically in space. All points vibrates with same frequency. All these points vibrates with same frequency. All these particles possesses energy, but there is no transfer of energy from one particle to another particle. Here, therefore, velocity is 0. Then all particle in one loop having same phase and it travel in same direction. That is, there is no transfer of energy. Then next is here particles vibrate in same phase travel along same direction. And particle in adjusting loop vibrate or it is out of phase and travel along the opposite direction. This is the properties of an stationary wave. In last lecture we have discussed about that, and longitudinal and stationary waves are produced. We can draw this diagram. That is, when longitudinal wave is formed, the node is formed at the close end, antinode is formed at the open end. This is formation of transverse wave, and this is the formation of longitudinal wave. In this diagram, we can say that node and antinodes are alternatively produced. That is, node and antinodes are alternatively produced in this diagram. This is the formation of longitudinal wave and this is the formation of transverse wave. Resultant wave is in the form of longitudinal wave, and after that we can discuss about that difference, comparison of progressive wave and stationary wave. This is the properties of stationary wave. After that we can discuss about the difference or comparison of progressive wave. After that we can discuss about the comparison of progressive wave and stationary wave. What is the difference between this progressive wave and stationary wave? For that purpose we have to consider here some point. First point is, in case of progressive wave, disturbance is produced. moves. In case of progressive wave, disturbance is produced and it travels from one region to another region. In case of progressive wave. But in case of stationary wave, disturbance remains in the region. Disturbance remains in the region. Remains in the region. In the region. Here velocity of this stationary wave. Here disturbance produced which travel from one region to another region with definite velocity. But in case of disturbance remains in the region and velocity of the wave is 0. Or then second point, amplitude. Amplitude is same for all particles. Amplitude is same here in case of progressive wave. Amplitude is same for all particles. In case of stationary wave, amplitude is different. Amplitude is different for different particles. Here, amplitude is different for different particles. This is second point. Then third, in case of all particles, in case of progressive wave, all particles are in moving position or all particles moves. All particles are in moving position or in move from one region to another region. In case of stationary wave, particles at node is always at rest position. Always at rest. The particles in case of progressive wave in an moving state, it will travel from one region to another region. But in case of stationary wave, particles which are present at the node, it always remains rest. It does not move. Therefore, we can say that amplitude of this node at the node point it is 0. Then here energy is transferred. Energy is transfer. Energy is transferred from one region to another region. But here there is no transfer of energy. There is no transfer of energy. Then after that, next point is particle crosses. In case of progressive wave, particle crosses their mean position simultaneously. But in case of stationary wave, particle crosses their mean position simultaneously. But this does not happen in case of progressive wave. In stationary wave, particle cross their mean position simultaneously and it moves. But in case of progressive wave, it does not happen. In case of stationary wave, the particles which are between the two successive nodes, it travels or it moves in the same direction and it is in a same phase. But the particle in an adjusting loop are travel in an opposite direction and differ by the phase 180 degree. But in case of progressive wave, phases of adjusting particle are different. Phases of adjusting particle are different. This is the difference between progressive wave and stationary wave. We can discuss here some points of this progressive wave and stationary wave. After that, we can discuss about the free and forced vibration. Free and forced vibration. vibration. Free and forced vibration. Free if the frequency at which object is hit or plucked or disturbed, then at that time the vibrations are produced. Then that vibration we can call free vibration, and corresponding frequency, it is called as natural frequency of that time object. It does not undergo any external periodic force. In last lecture we are discussed about that. If consider an example of a simple pendulum. When this simple pendulum, consider here, simple pendulum is displaced from their mean position, and it is released, then it performs free oscillation with natural frequency. This is the simple pendulum. When it is pulled aside and released, and force is withdrawn, then it performs free oscillation, and corresponding frequency we can call that natural frequency of the free vibrations. Also, another example, in case of string, it is in case of guitar, we can pluck this string, then it also performs the free oscillation and it vibrates with the free oscillation, and corresponding frequency we can call that natural frequency. In case of free vibration, object is pulled and body or object it is pulled aside, and force is withdrawn or force is taken out, and body it remains in its motion about its own axis, and that vibration we can call that free vibration. Then in case of free vibration, body oscillate about its own axis or it remain in a continuous motion. During this time it loses continuously its energy, and therefore amplitude of oscillation goes on decreasing at that time due to frictional air resistance. Here when this pendulum is pulled aside and released, then after due to air resistance, frictional air resistance, the amplitude of oscillation goes on decreasing and it comes to the rest. And amplitude goes on decreasing and body stop, and there is no external force acting on that body. Then that vibration is we can call free vibration. Then after that, forced vibration. In case of forced vibration, we can apply some force on that body whose natural time period is different from that time period of force. The vibration which are produced due to by applying external periodic force, and therefore body vibrates, that vibration is called as forced vibration. And the amplitude of this forced vibration depends on the difference between the external periodic force and natural frequency. For example, forced vibration are in case of drill machine, we can see that there are forced vibration, body vibrate with it and on the basis of external periodic force. Also in case of washing machine, we can see also that the work on the principle of forced vibration. Also in case of tabletop, body vibrate with the external periodic force due to tuning force of different frequency. then that vibration we can call that forced vibration. The body vibrate by applying some force, external force on that body, and that body vibrate. Therefore, that vibration is called as forced vibration. And this vibration depends on, amplitude of this forced vibration depends on the frequency of external periodic force. External periodic force. Periodic force. Frequency of external periodic force and natural frequency. Natural frequency. The difference between amplitude of this force vibration depends on frequency of external periodic force as well as the natural frequency. If this difference is small, then amplitude of vibration is large. Amplitude of vibration is large, or vice versa. If difference is large, then amplitude is small. If difference between this frequency external periodic is small, and then at that time amplitude of vibration is large. Also in last lecture we are discussed about that if object, we can consider the two pendulum, and if first object, that is oscillate about its own axis, it is in the set into vibration, then it vibrates with natural frequency and it causes nearby an object, that is it undergoes forced vibration on another pendulum. Then another pendulum performs force vibration. If first object is brought in second object, then at that time second object absorbs the energy from first object, and therefore it undergoes the forced vibration. If frequency of external periodic force and natural frequency both are equal, then resonance occurs. Therefore, resonance occurs if this both frequency of external periodic force and frequency of natural frequency both are equal, then at that time resonance occurs and body vibrates with maximum amplitude, and therefore in resonance, that what is called as resonance. In case of string as well as air column, vibration produces force, it undergoes the forced vibration. It also undergoes the forced vibration. Therefore, resonance occurs and loud sound is produced. On this basis of free and forced vibration, we can also discuss about the harmonic and overtone. Harmonic and overtone. Harmonics and overtone. Harmonics and overtone. On the basis of this principle of forced vibration, string or air column, it undergoes the forced vibration. Therefore, when this string or air column, it undergoes it is set into vibration, then at the end reflection takes place and stationary waves are produced. And when these stationary waves are produced, then it consists of different wavelengths. It consists the wavelength as well as frequency of an oscillation. Then that mode is called as normal mode of oscillation. Normal mode of oscillation. And corresponding minimum, the minimum frequency of oscillation are called as harmonic. First harmonic or fundamental frequency. fundamental frequency. Next frequency we can call the second harmonic. And this fundamental frequency also overtone it is used to minimum frequency of an oscillation. It is called as first harmonic or fundamental frequency. And this harmonic for particular overtone, which is integral multiple of fundamental frequency, it may or may not be present on the sound. Overtone it is used for to indicate overtone. It is indicate higher frequency. It is used to indicate the higher frequency. Overtone it is the term which is used to indicate the higher terms. Therefore, the frequency, the higher frequency than the fundamental frequency we can call first overtone. We can call first overtone. And next higher frequency we can call second overtone. We can call second overtone. We can call the second overtone. After that, when this overtone it is the integral multiple of fundamental frequency which are present in the actually present in the given sound, and the harmonic which is for particular overtone, which is integral multiple of fundamental frequency which may be or may not be present in a given sound. This is harmonic. And to study about this harmonic and overtone, harmonic means minimum frequency of oscillation is called as first harmonic or fundamental frequency. Overtone means higher frequency than the fundamental frequency we can call overtone. First overtone, second overtone and so on. After that, to study about this harmonic and overtone, we have to know that is end correction. End correction. For that end correction. End correction. For that purpose, we have to consider the pipe closed at one end and pipe open at both ends. Therefore, we can consider here pipe closed at one end. Closed at one end and open at both ends. Open at both ends. Consider this pipe. Closed at this is pipe closed. Pipe closed at one end. Pipe closed at one end, and this figure represents pipe open at both ends. In case of pipe closed at one end, we know that antinode is exactly formed at the open end of the tube. When this pipe is formed at the open end, at that point, particles are free to move, and node is formed, which is at the closed end. Then particles are hardly move to free. Therefore, antinode is formed at the open end, and node is always formed at the closed end. Antinote is not exactly formed at the open end of the tube. It is formed at the beyond the open end of the tube. Therefore, at that air is free to move as compared to the air inside the tube. And when air in the open end of the tube is not free to move, therefore reflection takes place. At that point reflection takes place, and therefore antinote is not formed exactly at the open end of the tube. It is formed at the beyond the open end of the tube at a small distance, and that distance we can call the end correction. End correction. End correction. We can call that end correction. So during formation of antinote, it is not formed exactly open end. It is formed beyond the open end of the tube, where particles are not free to move, and therefore reflection takes place, and therefore antinote is formed exactly beyond the open end of the tube, and end correction occurs. That is the distance between open end of the tube, the distance between open end of tube, open end of tube, open end of tube, and position. The distance between open end of tube and distance between open end of tube. Then we can say that that distance E is equal to 0.3d. That distance we can say that position of an antinote and open end is equal to 0.3d. ED is inner diameter. According to Reynolds, this end correction E is equal to 0.3d, D is inner diameter. In case of pipe closed at the one end, for figure A, L is equal to L plus E. Then L is length of pipe, E is end correction. In case of pipe closed at one end, then length of corrected length is L is equal to L plus E. And in case of pipe open at both ends, then end correction L is equal to L plus 2E. This is the corrected length of tube. Here antinodes are formed at the both two ends, and here antinode is formed at the one end. Therefore, here corrected length is L plus E, and for pipe open at both ends is corrected length is L plus